Hello, 8th graders. This is part 2 of our Chapter 3 Plate Tectonics unit. Okay, we stopped yesterday after talking about how um, plates, tectonic plates that are made from lithosphere moving around on top of the asthenosphere can move in 3 different ways. They can move together, they can move apart, or they can move side to side. And different things will happen depending upon how those plates are moving. So I want to begin today's lecture with this animation here that does a nice job of combining all of those different kinds of movements with what we see on land when that happens. So we'll start out with what we talked about yesterday. Right here, we have a convection current happening in the mantle. Okay, and what I mean by that is hot mantle is rising, it's moving laterally, cooling, and sinking. Moving laterally, heating up, rising, moving laterally, cooling, sinking. And that continually happens, and it's happening over here too. Well, when that happens in this direction here and in this direction here, what's going to happen is that mantle comes up, it moves apart, and it's going to drag those plates apart. And mantle is going to push up and create new seafloor right here. Okay? So when we have plates moving apart right here, that's called divergence. They are diverging from each other, divergent boundaries. And we are going to see seafloor spreading. Let's look over here. Over here we have the same kinds of convection cells that are moving laterally. Mantle is rising, it's heated and rises, it moves laterally, it cools, it sinks. And same thing is happening in this cell. It's pushing these two plates together. Okay? Well, a couple different things can happen. If they are both continental boundaries, meaning it is a boundary that is made from continents lithosphere and continental lithosphere, and they push together, if they have the same density, they will push up and it can be a mountain building event, okay? The Himalayan mountains are an example of continental and continental coming together. But more often than not, if you look around the tectonic map, where you see plates coming together like this, one of the plates is oceanic lithosphere and the other is continental lithosphere. And what happens because they are different densities is the denser of the two, which is oceanic, will subduct or push underneath the continental lithosphere. And you see that happening right here. This oceanic crust is being pushed underneath this plate right here. And what happens then, and I can show you a, I think maybe I can show you an example of this in class, but it creates these mountain ranges inland that are volcanic. Okay, so let's think about the west coast of the United States in Oregon, Washington, Oregon, and Northern California. Okay, you've got the edge of the North American plate is there, and then there's this little plate called the Juan de Fuca plate that's made of oceanic crust. Okay, so that is out in the Pacific Ocean, and that little plate is pushing underneath the North American plate, and what happens is then inland from the coast, inland from the boundary of the North American plate by about, I don't know, 150 miles or so, you are going to get a whole range of volcanic activity, a whole range of volcanoes. And that's true. If you look at British Columbia, Washington, Oregon, Northern California, all of the volcanoes that are in that area are about the same distance from the edge of that plate. And that's because these two plates here are converging. And we are going to talk a lot more about what's happening underground here that actually makes these volcanoes form. We'll talk about that when we get into the chapters on volcanoes. Okay. Let's see. There's a couple other little. Another way that that we can get volcanoes, and we'll talk more about this as well when we get to our volcano chapter, but another way that we can get volcanoes is through a deep mantle plume. Okay, so if you think of Hawaii and we look at the map, and I'll show you that in a second, but the volcanic islands of Hawaii are not near a boundary like this right here. Okay, they're right in the middle of the Pacific plate. And what happens with those is that there is some sort of a mantle source shooting up through the middle of a plate. See how here's a plate edge and here's a plate edge? This is like kind of like a, if you think of a big turkey baster with mantle that is pushing up through the crust, and it is making these volcanoes. The only volcano in this whole volcanic chain that is going to be active is the one that's right over this mantle plume, right? This whole plate continues to move like a conveyor belt. So all of these islands were formed when they were over this mantle plume, but as the plate continues to move further away from it, these volcanoes then become dormant or extinct, meaning they are not fed anymore by the mantle. All right, and that's true in Hawaii. All right, we'll go back here and just take a look at the tectonics map. Okay, so if you look carefully at this map, it's kind of hard to see at a glance because we're so used to these colors representing different continents, but you can see here is all of North America right here. And all of North America, along with half of the Atlantic Ocean, that is all on this one plate. And that one plate is called the North American plate. Okay? It has different kind of boundaries depending upon where you look. Over here in the Atlantic, we have divergence. These plates are moving away from each other, which is why we have seafloor spreading happening in the Atlantic right here, right? The seafloor is pulling apart and new mantle is coming up to form new seafloor. Over here on the west coast, as you would expect, we have an area that has a boundary that is responsible for a lot of earthquakes. And we know that we get a lot of earthquakes in and around California. And that's because this boundary here is moving side to side. It's a transform boundary, moving side to side. And then up here, we have a convergent boundary. See how the arrows are pointed towards each other? So these two boundaries are actually pushing together and one is subducting underneath the other. Okay? That is going to happen. Subduction will happen more often when we have continental and oceanic crusts or boundaries meeting. If you look over here, right above India here and the Indian plate, this is also a convergent boundary, so they're pushing together, but this is over land, right? This is land and this is land. And so they're pushing together, and what happens then is you get big, jagged mountain ranges like the Himalayan mountains. You can see that if you look like on Google Earth, and we can do that in class too, you can see that there's actually some pretty jagged mountains right here. Another thing to take a look at if you look at Google Earth is this divergent boundary here. You can see this mid-Atlantic trench on Google Earth, but also take a look at Iceland. Iceland is right here, and if these two plates are being pulled apart here and here, that would mean that Iceland itself is being pulled apart. Okay, and you can actually see that scar right on Earth. You can see where those two plates are pulling apart, and it creates this kind of passageway into inner Earth, and this country has a lot of geothermal heat coming out of it because these plates are pulling apart from each other. So there's a lot of interesting things if you just kind of picture how the plates are moving in these different areas, it will give you clues as to what types of tectonic activity happen in these different places. And we will be, as we move on through the book, there is chapters on each of those kinds of events. There's chapters on volcanoes and earthquakes and tsunamis, okay? Just to review, one of the biggest parts that I wanted to convey in this portion of the lecture are these three terms. These are vocabulary terms. Divergent is two plates moving away from each other. They're going this way. Convergent is the opposite of that. They're coming together. And transform is when they are moving side to side. All right, so we'll write those words down in class on some flashcards. They're going to be three important terms for you to understand as we move forward. I will also post this video right on the Google Classroom with a thought question as well. Okay, so your assignment today is to watch my lecture here and then also watch this video and answer the question that I post with it. Okay, I'll talk to you soon.